Enterprise Besu design succeeds when the architecture reflects real multi-party needs, clear governance, strong security, and shared value. In this topic, we'll compare proven patterns with common anti-patterns, so you can recognize designs that strengthen blockchain solutions and those that quietly weaken them. You now have the Besu Foundation, what it is, where it fits, and how its architecture works. From here, we'll connect those ideas to practical design patterns and to the mistakes that often cause enterprise networks to struggle. Enterprise Besu networks rarely fail because the code is missing. They fail when governance, privacy, compliance, and operations are improvised. Design patterns help turn those recurring pressures into choices architects can apply with confidence. Start with trust boundaries, not technology. Ask who participates, whether their interests align, and who must validate the facts. Then decide what truly belongs on-chain: shared state, proofs, agreements, or audit records. Keep sensitive data off-chain when privacy requires it. Clarify permissioning, validator ownership, and governance early. And challenge the premise: if a conventional database or integration layer solves the problem with less complexity, blockchain is not the right fit. A consortium pattern spreads authority across several organizations instead of giving one company control. Members can run nodes, and validator responsibility is shared, so the network is more resilient and harder to dominate. Governance becomes the operating agreement: who may join, how changes are approved, how disputes are resolved, and when upgrades happen. Besu's permissioning and privacy capabilities help enforce those decisions, keeping collaboration controlled while the blockchain remains shared. Before a consortium network goes live, governance needs to be explicit. Decide who can admit members, approve validators, authorize smart contracts, and trigger upgrades. Define voting thresholds, emergency powers, and the normal change workflow. Onboarding should also be repeatable. Verify identity, provision the node, update permissions, and complete compliance review. A useful pattern is to separate technical administration from business governance, so operational fixes can move quickly without bypassing formal member rights. In a shared audit trail, each organization keeps its real documents and business records in its own secure systems. When an event occurs, the system creates a hash, adds a timestamp and event reference, and writes that proof to Besu. Later, any party can hash the original record again and compare it with the on-chain proof. A match confirms the record has not changed, creating trust without exposing sensitive data or relying on one central database. The key design principle is separation. Sensitive payloads such as invoices, customer records, and contracts stay in controlled enterprise systems. Besu stores only evidence: hashes, timestamps, event IDs, and signer information. Verification happens by recomputing the hash from the source document and comparing it with the blockchain entry. This gives participants shared auditability while leaving retention, deletion, and access policies where compliance teams can manage them. Tokenization turns an asset or right into a shared programmable record. In a Besu network, that record is usually a smart contract defining who owns the token, who may transfer it, when it can be locked, and how settlement occurs. The token might represent goods, digital rights, loyalty value, carbon credits, or collateral. The hard part is not creating the token. It is making sure the contract rules match legal rights, business controls, permissions, and accounting treatment. A strong token model starts with architecture, not code. First, decide what the token legally represents: cash, an asset, a claim, or a workflow right. Then define its life cycle: who can issue, transfer, freeze, burn, redeem, and settle it. Enterprise tokens also need identity, permissions, compliance checks, and back-office integration. Finally, plan for real operations, including disputes, reversals, errors, and lost keys. Blockchain state only works when it connects to enforceable business meaning. A blockchain is not a secure document repository. If personal data, contracts, trade secrets, or large files are placed directly on-chain, every node may replicate them, and removal can be difficult or impossible. Encryption helps, but it may not protect confidentiality forever. The better pattern is to keep sensitive data off-chain, then store hashes, commitments, references, tokens, or zero-knowledge proofs on-chain aligned with retention, privacy, and security requirements. A permissioned Besu network can appear decentralized while still depending on one organization for validators, hosting, and operations. If that party fails, is compromised, or changes policy, consensus and trust are at risk. A stronger pattern is shared validator governance. Multiple consortium members own validators, run them across providers and regions, and agree on clear rules for admission, removal, monitoring, and recovery. Diversity turns consensus into a real multi-party control model. This failure is not about Besu itself. A consortium launches without clear rules for membership, upgrades, incident response, or contract changes. One group moves to a newer Besu version while others delay. Validators drift out of sync. Monitoring ownership is unclear, and the upgrade stalls. The fix is governance before production. Named operators, voting rules, release procedures, emergency authority, and lifecycle management for the network as a shared product. Two issues can quietly undermine an otherwise solid Besu design. First, keys are production assets, not developer details. Use HSMs, vaults, or managed signing, and define rotation, recovery, revocation, and separation of duties before launch. Second, confirm that blockchain is actually needed. If one organization controls the workflow, a database may be faster and simpler. Treat both questions as a production readiness gate and revisit them whenever requirements change. Enterprise Besu architecture works when governance, privacy, data design, and operations fit together. Use consortium governance for shared control, audit trails for tamper-evident records, and tokenization for programmable assets. Avoid sensitive data on-chain, centralized validators, weak keys, and vague ownership. Next, you'll turn these patterns into contracts and applications.